Hello. All right. Well, I'm sorry that I angst quit the last. Well, I'm not sorry. I'm glad I did it. But I didn't delete the video because there was some audio. I sort of have this OCD-ish thing about don't delete videos. I think they're kind of going in an archive. Um, that history will be able to persist. I mean, it's YouTube content and content on big websites is so redundant. It's a safe bet that people will be able to recover it in a long time from now. And somehow I think it's a waste to delete even a crap video. I will if that one was on the edge, but obviously I decided not to. So, one thing is Gary complains a lot that I haven't watched more of his videos or how close I'm paying attention when I watch one live, Generally, when I'm watching them live, it's because if I reply to it when I haven't watched it live, I watched it once and then I watched it again, and again, and then I do my notes, it's like, and I've already admitted that, yes, I believe we all scan videos. I don't think Gary notices everything I've said. I've said a lot of things he's never answered. And you could say, no, he probably answered them in the part I didn't watch. Fine, that's why I don't whine and bitch about this aspect of it. But I've watched many hours of Gary's videos on science for years and years. The first time he ever blocked me was because he was saying that that something could go twice the speed of light. Like if a spaceship was traveling away at a certain speed, that everything adds up, and there was and then he backed off of the fact that there was an absolute reference frame. There is no absolute reference frame. When I was in college, I had to do the Michelson-Morley experiment, and it convinced me that there is no at-rest reference frame. There is, and if there was, there's other issues in science that show that how would you ever get a hold of it? How would you know that you drifted from it? There's no way to rectify that, really. I guess there would be techniques to locate yourself. But they would fail at rather large scales, right? You can't tell from the stars if you're 100 miles here or there. You can't tell where you are in the Earth from the change in the stars, right? You can tell roughly where you are in the galaxy. But anyway, I find that annoying and petty and stupid because he doesn't like the fact that his system, I do understand what he's going for. Gary is claiming to have a better qualitative explanation that will lead to the same mathematical result, right? Now that's funny that he would claim that, since he also claims that the mathematical result doesn't match what we currently see, right? If the current mathematics don't match what we currently see in optics, because this 1 and 2 slit stuff is just baby steps. Optics is lenses, lasers, different frequencies, mirrors. The light can be, which is wave-like, can be coursed around very complicated things, and cheaply now. There was a time when people didn't think we'd be able to make lasers so cheap we'd, be able to put them in consumer electronics, like a Walkman. Did they make the Walkman as a CD version or whatever? That's because they actually know how the light goes, and they do have the math right. And that's why Gary says that his system will have the same math, right? So there's, and he's saying his is a better qualitative approach means he's saying it's more intuitive, it's more natural, it makes more sense, it doesn't have woo-woo stuff, right? Uh, and the thing is, I don't find Gary's system at all common sense in any way. I don't find it sensible or natural or of course, right? I don't find the fish metaphor useful at all because I'm looking for something more like a rock tied to a string being spun around, something physical and connected in my common sense, which, I don't think the fundamental laws of the universe submit to common sense, and that's because we've evolved very specifically to live in our jungles and our deserts and everywhere humans have lived on Earth, and not in some realm of particle interactions at the most fundamental level. So I just don't think the brain was built that it's going to make sense right away. However, I do believe that evolution and the flexibility of the brain allows us to figure it could get it. I'm not one of these people that believe that, well, just because of the size of the brain, you'll never figure that. No, it's metaphors. There's keys to this to understand it better. We know that already. Right, let's say that the way the Earth was discovered to be round was somebody walked and boated all the way around it. They just went in one direction all the time. They could tell from the sun and the stars. They kept going in one direction, and then, holy fuck, I'm back home. Then he has to have a theory. Does his home exist? Copies of it? No, I mean, how could that be? Well, and he would, one theory could be, well, it's a circle and you're wrapped around. That would be evidence for that theory. But I don't find these colored arrows. And you say things like, what did you say? I didn't put this in my notes, but I wanted to remember it. Oh, yeah. Electrons don't like each other. You're talking about the collision, and you're like, well, the electron doesn't. Why? Because they're both negative charge. You do understand, right, that what you're doing when you're taking on quantum mechanics is you're trying to come up with, among other things, an explanation of why there's magnetism. Just relying on it and saying, well, they don't like each other is not competing with the modern physics that you're trying to reject. And you are trying to reject it because you say your math would be the same math. But you don't seem to understand that the model you use, the purpose of one of the values of a model is it constrains the math. Looking at the model, you can go, oh, well, there's 5 of those, and they push like that, and the way those combine makes this twice as much, or it makes this equal to this plus that, or it's amplified. A lever works, and you can, from your model, you come up with ratios and relationships that you can use to find out what the equations are, or even a whole new kind of math if you want, a pattern language based on the relationships, the linkages between the elements of whatever you're trying to predict. Right? And your system of arrows that flip back and forth their color and stuff, that math with those items does not match up to what we actually see. That's my position. It can't match up to what we see. It cannot, because that model puts constraints on the situation about how things work. For that model to be apt, there would have to be different facts that we see. And I'll get to more on this in a second. Another way of putting it is, the math that would come from such a system does not match the results we see. And one reason I know that is because we see results like relativism, where a body not under acceleration that seems like a zero velocity to them and somebody else who's traveling relative to them but is not accelerating, that they feel the same way, physically, there is no difference. That's the beginning of relativity. That's the Galilean side of relativity. Einstein merely said, wait, I could tell how fast you're going by shooting light at you. There should be a Doppler effect. We should be able to tell, right? Like a water wave, when it's moving along in the water, if a boat can go the same speed as it, it can catch up and go right. A surfer can ride that wave. And you can't do that with light. When you speed up, the light in front of you does not slow down. It just gets longer. It stretches out. It changes its wavelength. How could that be? The only way that could be in the equations that work is if time does something weird, and that's why Einstein said, yeah, and that's what's going to happen. And people are like, no, I don't think so. And then it was measured and it happened. And forget the eclipse experiment. I'm happy if you want to reject that. But since then, we've put atomic clocks that are, and you go, well, the clock is broken. What's that mean? Everything's a clock. Your chemistry is a clock. If it's slowed down, your whole body, all the chemistry in your body, then yeah, you'd be aging slower, but you'd also be thinking slower, so you wouldn't notice any difference. And that's what happens. If you want to call that broken, the part you're not accepting is one of these I love the way Gary was like, well, it can't be true because there's just crazy, weird contradictions and paradoxes in it. No shit, Sherlock. That's why we've been talking about it, all this thousands and thousands of people, ever since it came up and was proved to mathematically predict correctly. It's like, how is that possible? And people are very eager to find alternate ways that it could be possible. And frankly, there is no other way so far. Yes, one could happen, but it's not going to be one that just denies that it happens, right? Your system where that's not true and they're faking it, that's not going to happen. That's not the theory that's going to come true. They were just lying. Nope. All right, so here's the thing about explanatory power that you also don't get. If your system, or his system, depending whether you're Gary or not, if it predicts exactly the same mathematical results, meaning, the same experimental shapes that happened have been fitted with a mathematical equation, and Gary's math did come out to be equivalent. It wouldn't be the same mathematical formula in the following way, or not necessarily, but it would come out to the same answers. And so let's say, for example, let's see if you can see that. Okay. So let's say you have a box, a black box, that you can put two numbers in and one number comes out, right? You put a 3 and 7 in and a negative 40 comes out. You put a 4 and 3 and a what is that? A 7 comes out. You put a 3 and a 1. Oh, and I didn't do that one. That would be 8. And an 8 comes out. And you do that thousands of times, looking for the pattern. All right. So you end up calling the first number X and the next number Y, and you come up with this equation. X plus Y times X minus Y. And simultaneously, another researcher on the other side of the world comes up with X squared minus Y squared. Well, many of you might recognize that those two formula give the same answer. X plus Y and X minus Y times each other equals X squared minus Y squared. All right, but in a computer and for a human, like mathematicians, and some of you probably out there right now saying, well, those are the same thing because they, it's just one form or the other of the equation. That's fine for math, one form of the equation or another, though I would notice it takes time and energy to convert, if you have one, to convert it into the other. But be that as it may. For a computer calculating these formula, or a human, these are different. These are significantly different. This one on top has 2 additions, 1 multiplication, and 1 negation, right? X minus y is an addition of a negative number, negative y. So you have to negate y, and then you have an addition. So it's 2 additions and a multiplication, 1 negation. This one down here, interestingly, has 1 negation as well. But it's got 2 multiplications and just 1 addition. Well, guess what? For humans and in a computer, multiplication is more complicated. Even a computer has to do multiplication the way we do it, with partial sums where you multiply and shift over and stuff. It does that in binary math, right? And when you have a floating point number, it does the mantissa and the whatever. It multiplies the number part and adds the exponents. It's more complicated. So having 2 additions and 1 multiplication will take less time than the other way around. And they both have 1 negation. It'll also have different values, right? The 2 will have a different value, right? If they're both really big numbers, then x squared and y squared are going to be really big numbers. They might not fit in the variable. They might be too big. They might be a bigger number than a 16-bit number could hold, or whatever you're using to hold that value, right? Whereas if they're both big, then x minus y won't be big. It'll just be their difference. It'll be smaller. And x plus y will be big, but not as big as x squared or y squared. So it's very different how much memory is taken up to store the numbers, right? And right, so they're very different. But if this is a black box, here, it doesn't matter to me which it is, right? I don't know what's going on in there, then I can think of it as either one. When I do I can use the one that works faster in a computer. I can use x squared minus y squared because I like it better. Right? It wouldn't matter if one was woo-woo, right? Because here's what the metaphor is that I've set up, is that these 2 sides here, these are the experiment, and in the middle is the phenomena that the experiment's provoking. You know, this number, you know, the first x could be the pressure, and y could be the temperature, or x could be the height of the object, and y could be the weight of the object, whatever. And then in the middle there's a phenomena of some sort and an output measurement, right? These are input measurements where I've gotten something that's exactly 3 pounds. I've been very carefully made sure it's 3 exact pounds, as much as I could, down to the to the milliounce. And so it's been heavily measured. It's been manufactured, but that has been a careful measurement process is involved. Then some unknown process is happening, and then we get an output number. If this is a black box, and we'll never see the arrows, we'll never see the quarks, it doesn't matter which it is. People could believe whichever they wanted, and it would make no difference whatsoever, right? Plus, your system of arrowtons is not more common sense. Not to everybody. I don't find it common sense. I find it incoherent. I don't even just find it, it's like a similar difference is you can describe any point in a two-dimensional space either with an x and a y, Cartesian style, or with an r and a theta, right? Polar coordinate style, a radius and an angle. Also implicit in both of those is an origin point and two axes that are oriented, right? So that's an extra bit of information involved. Both of those have that, and it's two-dimensional, so both of them have two coordinates for any that define any point in that two-dimensional space. And you can use either one of them. Most of us are more used to x and y than r and theta. But r and theta are very nice for some things. For one, it makes for a very simple equation for a circle. Just r equals 5. That's a circle. So those are alternates. And if the universe internally was one or the other, the universe was one or the other, if we couldn't figure that out, maybe there's a way you could figure out to pry that open to tell the difference, right? But if it was a black box, right, and what you're telling us is that you, instead of multiverse, instead of waves, you're giving us a particle explanation. Well, if I was just a person that liked waves, it wouldn't matter. I could use either of those two equations, whatever. If I like waves, if they're more comfortable for me to work with, then I think of it in terms of waves. Why? Because that makes sense to me. You like particles, you would think in terms of particles. And that's destined to be the case if you're actually telling us that all the numbers we've measured are going to keep coming out the same. All the inputs to the equation, the wavelength of the light and blah, 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 how many slits or how many mirrors, whatever, that stays the same. Then this will stay the same. And you're just saying, but I have a more likable explanation for this middle chunk. Well, fucking thank you very so much. I don't think it's very sensible, so that doesn't do me a shit ton of good, does it? I don't think the fish metaphor, right, doesn't make sense. Because why do they have to be fish? Because they swim in a circle like when dolphins capture fish and they make them swim in a circle, or when they whirl along on their own. I mean, I get the part of that they're swarming, but we're past that in science already. It's more like magnetic or the attraction, the forces are in equations. It doesn't require a metaphor with an animal that decides what it's going to do, right? So living animal metaphors don't really fit that great in physics right now. Do they? No, they don't. Because we're supposed to explain exactly what's causing them to turn, not just say, well, it's a fish. It could turn when it likes. And then I know you're going to say, well, other times I say it's not like that. Yeah. How do they go? And again, it doesn't necessarily matter, does it? Because it's all going on in a black box. You're not changing any of the predictions, right? And if the math fits the predictions, and your particles eventually do, which they won't, because different models constrain what mathematics can be used. Your model ignores certain things like the relativity of motion, like the fact that the pattern is not the same between 1 and 2 slits. It's merely related. The similarities you might see are because they're related, and you don't even seem to accept diffraction around an edge as being a factor of how this stuff works. You don't understand that Huygens is about how a wave, that line or part of a circle, either one you ever see, I mean, because I've been at the ocean and I've seen waves that look really straight, right? So maybe it was straight. They're often crooked and jagged, whatever, but it's a line. The propagation of that wave is itself an interference pattern, because waves are always interfering. Interfering is when you have two waves that a human would identify as separate, how they pass through each other and what happens when they're overlapped, right? And what Huygens was saying is that when a wave front is propagating along, that's the same thing. Why is that happening? Because the wave is actually all of these parts that are affecting their neighbors and moving. And so it's like a cellular automata thing almost. And it propagates because of this effect, which relies on interference at every single moment in its propagation. So going, I noticed diffraction lines are like interference lines. Well, you weren't the first ones, were you? No, you're like 300 years late or some shit. That's why diffraction is proof of that something is wave-like. Because look, if you have an edge like this, no slit, where you would have a slit, you just cut the screen in half, and you have this. So this is all open. And there's the edge. Well, if you shoot particles at this edge, it's going to make a straight shadow. Some of the particles will bounce off inward, right? But none of them are going to diffract. None of them. None of these particles that hit that edge are going to bend into the edge. But when you put a wavefront, coming along here, and it hits that edge, it does bend. It cones. And that's what light does. And shotgun BBs don't do that. But that's what light does. But not shotgun BBs. Not drops of water. If you ever saw something like that, it would be because in addition to the drops of water, there was wind pushing it around the corner. If it's just being shot, it's going to be masked at that point. It's not going to cone out. When you have a slit, you can imagine, well, the ones bending out, they're bouncing off the other side of the slit. Yeah, well, diffraction doesn't take two sides. Diffraction happens with one side. And you can actually see the diffraction of light with your own eyes around a sharp edge. Yeah. There's a little blurry line where the light is a weird light effect that you could tell is diffraction. Anyway, too much time on that, probably.